at some point during your printing where you load a roll of media in and you measure it and you find out that it shrank. So let's say the media is supposed to be 8 feet long and you get 7 feet 11 inches or 7 feet and 11.5 inches. And you're thinking, what happened? Well, what happened is there's a certain amount of heat used with a latex printer. Now that can vary. You could be anywhere from, say, 165, 170 degrees Fahrenheit, all the way up to 241 degrees Fahrenheit. That's the max. And then you have speed along the way, which will determine how much dwell time the media has exposed to the heat. With that understood, not all medias are the same in terms of their sensitivity to heat. And there's two characteristics of shrinkage which are very common. Most medias, usually, they shrink lengthwise. It's pretty unusual for them to shrink widthwise. Usually that remains stable. What happens is as the material prints, it shrinks just a little bit on the length. Now that's going to vary a lot depending on the media. To give you an example, what I have here on this roll is a 10-ounce PET super smooth blockout. This is a temperature-sensitive media. This is going to shrink and warp if you put too much heat on it. Now, if you were to take, say, a Herculite Bantex banner, which is a scrim banner, which is very resistant to temperature, you could put almost 241 degrees on it and not see one iota of change. Not all banners are built the same, and not all banners have the same amount of scrim, and so therefore not all banners necessarily resist heat the same way. That same is true of polypropylenes, which can tend, or synthetic papers, that can tend to shrink. Some adhesive vinyls can shrink. The monomeric is probably more prone to it than cast or polymer. Certainly some banners can shrink. Fabric, not uncommon at all, especially when you want to turn some heat on it, you will have fabric shrink some. That's something that traditionally fabric printers understand is kind of the nature of fabric printing. There's a wide range of materials that may shrink some more, some just a little bit, when you put some heat on it. So I wanted to explain that that's not unusual necessarily, and there are ways to compensate for it. This is particularly important for double-sided printing, and there are processes within the RIP, for example, to account for the shrinkage and then make the image ever so slightly larger so that when you print, you come out to the exact size that you intended to come up with. And that is in the scaling function. And in a second here, we're going to show you where that scaling function is in the RIP so that you can go into it, run a print, measure it, and then have it reflected accordingly. If you've already done the printing and you meant to, say, get 8 feet, and you come up with 7 feet and 11.5 inches, so you're a ½ an inch short, you can take that data, you measure the width and you measure the length of what you were supposed to get versus what you did get, and you can put that data into Onyx or Caldera or Flexi, and then for that media, that specific media, it will calculate for you in future jobs the difference in percentage that it printed versus what you intended, and it will make those adjustments automatically. When I do double-sided printing, for example, it's not uncommon for me to apply the compensation to side A, but not side B. You know, like, why is that? Well, because side A is usually the side that shrinks a little. By the time I've done that, side B, when I'm running back through again, really is not going to shrink, but you can measure that to make sure. So I want to compensate on the first side, but not on the second side. And I'll show you a little trick to kind of get around that and make it easy. It's not uncommon for medias. Let's say 20% of media shrink a little. Now you have some other options. When I run this 10-ounce Super Smooth, I am going to run this slower with controlled amount of ink relative to the pass mode I've chosen. So I would start testing this media at 12 pass, 190 degrees, and see how much ink I can put down on it. If you're willing to run just a little bit slower with a little lower temperature, you can reduce the amount of shrinkage. The more heat you're putting on, the more the material is likely to shrink, and then you have to compensate accordingly. So if somebody is stuck on, I've got to run 8 pass, but you need 235 degrees to run at 8 pass, you may induce a 1% shrink. If I were to run 12 pass at a significantly lower temperature, running the same ink density, I only might have like a tiny fraction of the shrinkage because the material is not being hit with as much heat. And putting less heat on it incurs less shrink, and so therefore I have less deformation with the length of the material. Those variables can be accounted for, and I do recommend going to a slightly slower pass mode so that you can put less heat, and therefore you do less shrink. I wanted to explain the concept, and then we're going to show you in a second here how you go into the RIP and make that adjustment. But it is something at some point where you're going to want to control for. And your two options are either control in the scaling. My preference is to control in the temperature, and sometimes I do a little of both. I'll split the difference. But that is a fundamental part about printing with latex and how you adjust for a temperature-sensitive media to adjust the scaling function. The location I'm going to show it to you will be in Onyx, but the same thing exists in Caldera and Flexi as well.